Well, good day, everyone. Welcome to the ATRA webinar series, and today's subject we're going to deal with GM 4-speed solenoid diagnostics. We're going to be talking about dealing with the shift solenoids on a GM 4-speed transmission, and also the 5-speeds are also done the same way. We'll probably be following this up with another presentation on how to do the PWM solenoids, as well as how to work on the new 6-speed, and what you're going to see is 8 speeds coming out here this year on the GM applications. So today's subject itself, we're going to be running around between 30 minutes and 40 minutes. A couple of things for you, a little bit of housekeeping. You can ask questions. So all you simply have to do is select the questions box, type your information in there, and it will pop up on my screen. And you should be able to see the information popping up here on my screen so I can answer in the timely manner for you. Now, I just got a question up from, it looks like from Grant. Grant asked a question about we're in audio-only mode. So that would be correct. At this point, you guys have all been muted, because if we don't do it that way, what ends up happening is everybody will hear everybody out there. So if somebody drops a wrench or a car runs through the door or whatever, everybody's going to hear that happening. So that's the reason we got you in audio-only mode. At the end of the presentation, we're going to try out the audio mode where we can actually unmute speakers. And so if you want to ask a verbal question, we'll see how we can make that work, since this is our third time in doing this. So we're kind of new at this whole operation, but we're going to try to get through it today and learn a little bit about it. At the end of the presentation, you're going to have a feedback slide, which basically will take you through a survey that we'd like to have you fill out. Let us know about how this thing actually worked out. Did you have a nice clear picture? Did you have good sound? Could you figure out how to type your questions in and so forth that you needed to have typed in? Did we answer the questions that you had? Is it the type of subject matter you want to discuss, and so forth? So without further ado, we're going to take you through a little bit of GM Solenoid Diagnostics and the presentation itself. Now, most everybody's aware that the solenoids that are used in pretty well everybody's applications are nothing more than electro-hydraulic devices. In other words, you're going to have a electromagnet, which is going to be your coil assembly, built into the solenoid, and that's going to have to control something, and the solenoid in this instance is going to be a check bulb. So this coil assembly that we're dealing with right here, this guy is nothing more than an electromagnet, and we're going to control both the power and the ground side going to it so we can energize this electromagnet. The magnetic field, of course, then controls the plunger and the ball, as you can see in the picture on your screen. That plunger and ball then simply control this exhaust, and we're either going to allow the solenoid to exhaust oil, or we're not going to allow the solenoid to exhaust oil, which means that the pressure on the end of the solenoid is either going to build up or it's going to be exhausting through the center of the solenoid. So by doing this, we can physically then control the position of different valves within the valve body. So the solenoids effectively, guys, are a very simplistic device. There's nothing razzle-dazzle or earth-shattering to it. The electronics is really what drives people nuts when it comes to trying to diagnose them. We're going to teach you today how to diagnose from the driver's seat. By the time you're all said and done, if you were to actually take a scan tool out to the vehicle and work with this a little bit, you'd learn how to diagnose a solenoid electrical failure or mechanical failure within just a few minutes of operation of the vehicle itself. So the way we're going to teach you how to do this is to use the information that's available on your scan tool. Now, if you look at the picture of the solenoid assembly itself that we're displaying across the screen, as you can see, we've got a 12-volt feed coming into our solenoid, and the ground side is actually controlled by your controller. That is called out as a PCM, VCM, TCM in your picture. So no matter what it is we call it, you're going to have some sort of controller that's actually going to be controlling the operation of the solenoid. Now, typically on the GM applications we've used for decades now, ground side control. This ground side controller has what's known as a driver built into it. That's fancy words for meaning a switch. So this device right here, this is your driver. It's an integrated circuit itself that basically controls the ground. When we have the driver shut off, so in other words, the solenoid is shut off, effectively what we're doing is we're opening this driver itself and preventing ground from occurring for the solenoid. That means there's no longer any current flow within the solenoid itself, and at this point, right at this pin, you would typically see battery supply voltage. Okay, because again, there's no voltage drop occurring within the circuit because you don't have any current flow happening. When we turn the driver on, in other words, the software says it's time for a shift to occur, the controller physically cycles that driver on, and when that happens, you're going to see this switch within the TCM going to ground. That's going to give you the command status on your scan tool. So you're going to see the command line on the scan tool physically go to the on position. When that happens, if we were measuring the voltage on this circuit right here with a voltmeter, you'd see that your voltage is typically going to drop to about a half a volt or less. That means that we're now having voltage drop occurring across the winding of the solenoid, so there's no voltage left effectively when it gets back to the PCM. So the voltage is being consumed by the load. And that's kind of key here that you understand that. The load has to be the device that's actually consuming the voltage in the circuit itself. Now, you're probably looking at this thing saying, well, that seems fairly simple. Well, it actually is fairly simple. It doesn't make any difference if we're talking about a 1-2 shift solenoid or we're talking about the 2-3 shift solenoid. They all work exactly the same way. This driver circuit is controlling the ground, and that's going to control the current flow through my solenoid assembly itself. Now, here's the kicker. By looking at a voltmeter on this PCM, VCM, TCM pin, we have just said that if the solenoid was shut off, in other words, the driver was turned off, you would see approximately 12 volts on this pin. When the driver circuit's turned on, in other words, the solenoid is cycled in the on position, and on your scan tool it says on for your command line, you will typically see a less than a half a volt on that pin. Now, what GM did many decades ago was we put in something called a feedback line. Now, you don't typically know that this is there other than you've got a display, usually on your scan tool, that says feedback on it. Most of the instances, you're going to see it abbreviated as FBK. So in this instance that we're looking at right here, it would be saying 2-3 shift solenoid, and it would be showing the feedback line as FBK. Now that feedback line effectively is a built-in digital voltmeter. So it's doing the same thing that we could be doing with a voltmeter hooked to the pin right here of the PCM itself. So without even having to hook a meter to the vehicle, I can tell what the condition and status of that solenoid actually is. Is the solenoid being turned on or the solenoid being turned off? Is the solenoid working correctly or not working correctly by simply monitoring the feedback line? Now, there's going to be different layouts for that feedback line. In other words, they're going to be displayed differently on your scan tool, and that really gets people confused because they look at one application, let's say you're looking at a 4L60E at 1 year, and the display on your scan tool looks different than the 4L60E of another year. That's because of the fact that they've used not only different software in these different vehicles, but they've also used different engineers to design the software system. So what it boils down to is that your displays may vary a little bit from application to application. But what we're going to do today is we're going to talk about how we can commonize those displays. Now, in order to understand any of these transmissions as far as your operations are concerned, we've put together a truth table for you on all the 4-speed automatic transmissions. All of your 60 series transmissions have the same solenoid firing sequence. So on your command line, on the scan tools, when you look at the commanded position, on a 4L60E, in first gear, both solenoids are on. Second gear, we turn the 1-2 solenoid or solenoid A off, leave B on. Third gear, both solenoids go to the off position. Fourth gear, we recycle the 1-2 solenoid or solenoid A back in the on position. We leave solenoid B in the off position. So effectively what we're doing is we're cycling each solenoid on and off 1 time or 2 times. So each solenoid in this instance is in charge of 2 gear ranges. Now, when you look at the 4L80E, The 4L80E, 4T80E, same family transmission, so this is the 80 series transmissions. They use the same solenoid sequencing. So in first gear, the 1-2 or solenoid A and solenoid B. The 1-2 solenoid is going to be in the on position. Solenoid B or the 2-3 solenoid is going to be in the off position. I go to second gear, both are turned off. Third gear, we're going to have A remaining off, and we're going to cycle B back on again. I go to fourth gear, the 1-2 solenoid or solenoid A is going to be cycled on, and solenoid B or the 2-3 solenoid will be cycled back to the off position. So if you compare these charts between the 80 and the 60, you're going to notice a couple differences. First off, the solenoid firing sequences are different, and secondly, the default ranges for these transmissions are different. If you noticed here, if we lost power to this transmission, which of course is very common with a lot of the GM transmissions, you got a bad ignition switch, bad fuse, bad wire, whatever it happens to be, and you lose power to the transmission, this thing in overdrive range is going to default to third gear. But if you had a 4L80E or a 4T80E and you lost power to that transmission, it's going to default to second gear. So again, the reason for that is the firing sequences of the solenoids are a little bit different. We look at the 4L30E, 4L40E transmission itself. Again, this transmission was built in France, and the engineering groups were different engineering groups, so they have the solenoid firing sequences different than either the L60 or the L80 transmissions were. So in this instance, we've got solenoid A or the 1-2 solenoid off at first, B or the 2-3 solenoid is on. Go to second gear, the 1-2 solenoid is turned off, 2-3 remains on. Third gear, we turn off the 2-3 solenoid to make it shift to third gear. Go back to fourth gear, we turn off the 1-2 solenoid to make it shift to fourth gear. So again, if we were looking at this, you're going to see this sequencing is different than either of the sequences above. Last but not least, you're going to notice the default range for this transmission is different. So again, if you're running this transmission in overdrive range, you're going to find out that this transmission will default to fourth gear. Now, that doesn't mean that fourth gear is your only gear available, or third gear or second gear if we're talking about an L60 or an L80. What it boils down to, guys, is this. You have a manual override with your manual valve. So if you want to slide the shift lever into a different range, you can manually override on several of these applications. But point being that there's a common denominator between all the 60 series transmissions with their firing sequence and their default range, and then there's a common denominator between all the 80 series transmissions and their firing sequence and their default range. And of course, the 4L30E is out on its own. So what you're seeing here is actually what you would have as your command status for your solenoid assemblies themselves. So when you look at your scan tool, it will say 1-2 solenoid command. It's either going to be an on or an off, or 2-3 solenoid command. It's either going to be an on or an off. That's what you're actually seeing on the chart. Now, each solenoid in a GM 4-speed transmission is responsible for 2 gears. Which 2 gears it's responsible for is depending on which solenoid we're talking about. So if we have a failure of a particular solenoid, you will always lose 2 gears. So if that solenoid sticks in the open position or it sticks in the closed position, you will always lose 2 gears. Which 2 gears is dependent upon which solenoid failed and what position the solenoid failed in. Is it stuck off or is it stuck on? So this chart is designed to show you what happens on an L60 or T60 transmission if the 1-2 solenoid had a fault in it and that solenoid happened to stick in the off position. Well, what you're going to find is this transmission is going to start out second gear. When it's supposed to be making it shift to second gear, it's going to remain in second. It's going to make its transition to third, but when it's supposed to go to fourth, your ratio would indicate you're still in third gear. If we were to stick that same shift solenoid in the on position, then you're going to notice it's going to start out in first. It's supposed to make the shift to second gear, so you're going to show on your scan tool you're commanding it to second, but the shift's not going to occur, so you're not going to see the gear ratio change. When it's supposed to go to third, it's not going to go to third, it's going to go to fourth. So this thing is going to actually skip, in this instance, second and third gear. Now if we look at the 2-3 solenoid, same basic story here. If we stick this solenoid into the off position, notice what you're missing. You're starting out in high gear, it's going to downshift to third gear, remain in third gear, upshift to fourth gear. You're missing first and second gear. If we stick it in the on position, Then we're going to start out in first, make our gear change to second, stay in second when we're supposed to make a transition to third. And now what happens, because this has happened several times to people and they get confused by this, the transmission's actually, if you can get going high enough road speed, it's going to make a shift back into first gear again when it's supposed to be going to fourth. So what it boils down to is that you do not have enough engine to run this vehicle down the road in first gear at highway speeds. So the vehicle acts like it's going to neutral on you. So by having a solenoid stuck, as you can see, the common denominator is you're going to lose 2 gears. Which 2 gears is depending upon which solenoid stuck and what position it's stuck in. Now the same thing is going to be true of the 80 series transmissions. So we're looking at a 4L80E, 4T80E, and of course the 4T40E has the same sequencing that the 80s do. So if we stuck the solenoids in the off position right here, the 1-2 solenoid, you're going to be missing, in this instance, first and fourth gear. If we stick the solenoid in the on position, you're going to be missing second and third gear. If we stick the 2-3 solenoid in the off position, we're going to be missing third and fourth gear. If we stick the 2-3 solenoid in the on position, then you're going to be missing first and second gear in this instance. So again, same common denominator, we lose 2 gears. Which 2 gears is dependent upon which solenoid stuck and what position it's stuck in. 4L30E, same process. 1-2 solenoid fault, stuck off, missing second and third gear. Stuck on, we're going to be missing first and fourth gear. 2-3 solenoid stuck off, we're going to be missing second gear and first gear. We stick it into the on position, we're going to be missing third gear and fourth gear. So with that said, we're going to give you a little quiz. So you should see popping up on your screen here, hopefully very shortly, a question. And that question is going to read, it says, if the solenoids to fail hydraulically in a GM 4-speed transmission, how many gears would be available? That's what we should see popping up. So I'm going to launch that. On your PC, you should be able to respond back with the answer, and we'll be able to see the answer back here at the office. And then once we've done the poll itself, we'll then put the poll results up for everybody to take a look. So you should be seeing the question popping up here on your display. So we need you to answer the question, pick out the correct answer, and in a minute or so, we'll pop up the answers that you guys gave us. Okay, looks like we got everybody that's voted. So now we're going to share the results with you. B, of course, is the correct answer. 96% of you responded to B. It does result in 2 gears being available for you. So good job. All right. Well, let's talk about electrical failures with our solenoids. We're going to categorize electrical failures into 2 types of failures. There's only 4 failures that can happen. So if you're looking at any type of electrical circuit, and I don't care what kind of electrical circuit you're looking at, you can have an open, you can have a short to ground, you can have a short to voltage, or you could have a shorted solenoid. Those are the only 4 things that can happen to you in any type of electrical circuit to deal with in any part of the automobile. What we're going to do, guys, is we're going to shortcut the diagnostics because we're going to separate opens and short to grounds from short to voltage and shorted solenoid issues. So we're going to separate what we're going to call out as low voltage failures from what we're going to call out as high voltage failures. So low voltage failure is going to be an open or a short to ground. Okay. A high voltage failure is going to be a short to voltage on the ground side of the solenoid circuit and a shorted solenoid. So rather than going after 4 items and being stumped of which of the 4 I need to look for, we're going to use the diagnostics built into this car to go after just 2 problems. So we're going to cut our diagnostic time in half by physically going through and looking for just those 2 areas that we may have problems with. So no matter how many failures we have available, which we just said there were 4 of them, we're going to use the diagnostics to help us figure out which 2 we need to actually look for. Now the diagnostics in a GM vehicle are laid out following one of these 4 processes right here. When this thing first all started out, you had this number 2 bullet that was what was used in a lot of the vehicles. And now we come back to that also in some of the later vehicles. It says we got sense line code settings. In other words, we can get a trouble code to set if we got a problem with the sense circuit. Then there's a feedback line. But you do not have the feedback line support on your scan tool. Now, this is the toughest ones to deal with. So you get a code set, but you go to look at the scan tool, and there's no data parameters that say feedback line on it or FBK line on it. So you only have the command status. If you have something like that you're dealing with, you have to set the car up for a snapshot or a movie. So you clear the trouble code, set up for a snapshot or movie, cycle your key back on, and you drive it through the gear range, letting it shift through whatever gears are available there, and you look at the range, or in other words, the gear that the code is set in. Was the solenoid turned off or on at the time the code set? That's how you're going to diagnose this. If the solenoid was turned in the on position when the code set, then that means you've got either a shorted solenoid or you have a shorted B+ in the solenoid circuit. If the code set when the solenoid was turned in the off position, then that means you have either an open solenoid or circuit itself or a short to ground in that solenoid or circuit. So that's how we separate these failure items on a vehicle that does not have feedback line support. They are the toughest ones to work with, but again, once you get used to doing this, you're talking about less than a minute to diagnose the car. So you put it up on the hoist, you clear the code, you set it up for a movie snapshot, you let the code automatically set, and you look at the gear the car was in and the command status of the solenoid at the time the code set. That will tell you what your problem is. Now, it does get easier than that as we move on. GM started putting what they called feedback lines within the software itself clear back in the early 1990s. But like I told you, some vehicles have them, some vehicles do not have them. If they do have them, they're going to be in one of 3 different formats. Your vehicles that use something called a quad driver module or a QDM style driver, they use what they call matching command and feedback lines. Very simple to use. Basically means your command status, if it says on, the feedback line has to say on. If the command status says off, then the feedback line status has to say off. Fairly simple to diagnose. They made it even easier yet when they went to what they called output driver modules. An output driver module itself is going to give it to you as a fault or an OK underneath the feedback line status. So we're going to have our command status if the solenoid's turned on or off, and it's going to either say OK or it's going to say fault. So you don't even have to interpret whether they're matching or not matching. The scanner is going to tell you that. Last but not least type of diagnostic routine that's out on the GM vehicle is the simplest of any of them to use. This display itself will actually display the individual type of failure you have. It will tell you have an open under the feedback line. It will tell you have a short to power under the feedback line. So it gives you a real easy interpretation of what's going on with the vehicle. Here's my feedback line, as you can see, and the feedback line is built right into the controller, and it's parallel to the driver circuit. So when the driver is turned on, he expects to see this feedback line at 0 volts. When the driver is turned off, he expects to see this feedback line at 12 volts. If we fail to see it at 12 volts, when it's turned off, we set a code. If we fail to see it at 0 volts, when the solenoid is turned on, we set a code. That's where the codes come from. So this status of this line will be displayed right on your scan tool. This is what you're going to typically see. This is an actual scan tool display right here. So under the 1-2 shift solenoid, you see the command status as being on right now. Under the 1-2 feedback on your scan tool, you see its feedback as being on also. These are matching. That is good. At this point, little Fred the computer right here, he is a happy, happy camper. Because these two lines are matching, it means the car is not broke. If we look at the 2-3 solenoid, you can see the command for that solenoid is off. The 2-3 solenoid feedback, it is showing it's off. So again, we are happy campers because these two lines are matching each other. Now you won't actually see the word match pop up on your scan tool. You're going to simply see the on and the offs on your command and your feedback line. So we're looking for that solenoid command status and that feedback line status to always match. If they're matching, there's not an electrical problem with the solenoid. So you can separate an electrical problem from a mechanical problem very easily by looking at the solenoid feedback lines. Because again, that's your built-in voltmeter. When you have a problem with the solenoid, it's going to appear like this on your scan tool. In this instance right now, I got the 1-2 solenoid commanded on, but notice my 1-2 feedback is saying no, it's not on. So we've got the solenoid commanded on, which basically means we're cycling this ground closed. So this ground is being closed right now. And so our voltage on our feedback line should be at 0 volts, but the controller is saying, no, it's not at 0 volts. It's something above 0 volts. So we've got a problem with the car. So when it says it's off, that means the voltage is high. Well, what would cause the voltage to be high? A short to voltage in the ground side of the solenoid, a shorted solenoid, or like any other failure you'd have in the car, of course, a problem with the controller. These are the two devices or two areas that we typically look at. So right now, they fail to match, so therefore the car has a problem. What problem is it? It's going to be a short to voltage or a shorted solenoid. Now in the picture below, as you can see, we've got the solenoid command being off for the 1-2 solenoid. The command line is showing it off, so that means right now this driver circuit is open, which means we're ungrounded. There should be no current flow in our circuit. So right at this pin right here, which is the same spot we've got with our feedback line, that feedback line should be reading battery voltage. Well, in this instance, it is not reading battery voltage. It's saying on. And with it saying on, that means that the voltage is low. So what's the only thing that can cause the voltage to be low? Well, it would mean we'd have a short to ground in the solenoid circuit itself. In other words, somewhere typically on the ground side. It could be on the power side, but that's going to blow a fuse. Or you got an open somewhere, like a bad ignition switch, or a bad wire, or a bad solenoid. So we're showing that the voltage coming back to the controller is low. So by simply taking the car out, operating it manually through the ranges, because that's all I'm going to do, put it on the hoist, you can click, 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 upshift and downshift the transmission, watching my feedback lines. At the same time, I'm watching my command status through all 4 gears. All of these should be reading the same. Anytime you have a mismatch, the car has a problem electrically. So that's how simple it is to use this diagnostic routine. Now, as I told you before, GM has changed their designs of their circuitry through the years. When they went to what they call output driver modules, they developed 2 types of diagnostics for those ODMs. They're displayed differently on your scan tool. We're going to talk about them and refer to them as type 1 or type 2. I'm showing you a type 1 display on in your picture right now. So right now, as you can see, we got the solenoid for the 1-2 commanded on. The feedback line is saying OK. That's good. As long as they say OK, we're happy campers. In the bottom picture, I've got the same solenoid command. The solenoid's commanded on, but in this instance, it's saying I have a fault. So we've got the solenoid commanded on, which basically means the voltage should be low, but we're saying the voltage is not low. That means we got either a shorted solenoid on the ground side of the solenoid circuit, or I should say a short to ground, or shorted to voltage on the ground side of the solenoid circuit itself, or a shorted solenoid. Or of course, just like we dealt with before, you could always have a bad controller. So it's the same type of process we just used with the matching lines, except for it's a little bit easier because it indicates to you in simple English it says fault. When you look at your scan tool and we've got the 1-2 solenoid turned off in this instance, if it says fault then that means we got a low voltage failure. That means, again, we're going to have either an open solenoid or we got a short to ground in the solenoid circuit itself between the solenoid and the PCM. Now, the type 2 diagnostics are even simpler than that. So the type 2 diagnostics, what you're going to run across there, is they give everything to you in simple English. So here's my command status. We've got the solenoid commanded on. And here's my feedback. 1-2 solenoid feedback, short to ground or open. Is it shorted to ground or open? No, it's not. 1-2 solenoid shorted to voltage or shorted. Is it shorted to voltage or shorted? No, it's not. So in this instance, as long as these two parameters right here read no, we again are very, very happy campers. Okay? When they do not read no, that's when things start going the wrong direction. So in this instance, as you can see, we've got the 1-2 solenoid commanded on, but it's showing again that the 1-2 solenoid has a short to ground. So again, when it displays no, that's when we have a problem. And that indicates to you in simple English what the problem is. I wish I could say again that all the vehicles were as easy as what we just dealt with to diagnose, but the ones that really give you troubles are like this 4T60E early design stuff, and now the later 4L60Es. They do not have feedback lines on some of those, and some of those do not even have solenoid codes on the early 4T60Es, but they do give you feedback lines. So there's a little bit difference as far as the layout's concerned. On those applications, you're going to have to, if you do not have trouble codes available, you're going to have to watch the feedback lines as you run it through the gears, looking for the feedback lines not to match. If you have the later model 4L60Es, like I looked at the 2009 as an example, it does not have any feedback line diagnostics on it. You have to look at what the command status of the solenoids were when the code set. That will tell you what your problem is. Solenoid commanded on or solenoid commanded off. All right. Feedback line diagnostics on 4T60Es as well as some of the other vehicles can also get a little complicated because the driver circuits that GM uses are not just controlling the solenoid. So as you can see here, I've got a TCC solenoid. This is one design of driver we've got. But you notice it's got a whole bunch of other things hooked to that driver circuit. What I'm trying to get you guys to understand in this instance is this TCC solenoid may not be working in your car, but it may not be working because of something wrong with one of these other components. So let's say we had a canister purge solenoid that had a problem. That's going to keep the TCC solenoid from working because a fault in any of these other components will keep these components you want to operate from operating. So my whole point to this, folks, is the fact that you may have an instance where a component on your vehicle is not working or not working correctly, but your diagnostics do not indicate there's a problem with that component or that component circuit. It's something completely outside of that. You have to go to your schematics and look up in your schematics on the vehicle what is actually hooked to that driver. Your diagnostics will give you that. So go to the diagnostic routines themselves. It will tell you what's actually on that driver circuit to help you isolate what could cause your component failure. So again, just a little tidbit for you there. It looks pretty confusing. It really is not. The big thing you need to keep in mind here is the reason your component may not be working may not be due just strictly to the component that you're dealing with that's not working. Feedback line diagnostics on the 4T80s. Been some big changes with the 4T80s also. When the 4T80 first came out in the North Star, you had the abilities to go in with your onboard diagnostics and checked the feedback lines. There were actually 8 fault lines built into the onboard diagnostics. Now, as most of you guys are aware on the Cadillacs, you entered onboard diagnostics by pressing the off and warmer button simultaneously on the driver information center or the control panel, and it would then take you through and allow you to look at the different parameters. Well, PD16 would give you the fault lines for the QDM A, B, C, and D. PD17 is QDM E, F, G, and H, and that's where we're going to be for our transmission is PD17. Now, this is going to get confusing for people. The display that Cadillac used was in binary code. It was either a 1 or it was a 0. A 1 meant that we had a problem. A 0 meant that we were happy campers again. So you normally think of binary code as highs and lows. Well, effectively, they used the same routine here, except for a 1 was bad, a 0 was good. Now, that takes us a step further. They used the same fault line for multiple solenoids. And so you'd look at the fault line based on the commanded gear you had the car in. So if the car was in first or fourth gear and the fault line changed to a 1, then it had to be a solenoid A problem, and it had to be a short to ground, or a short to voltage, I should say, on the ground side of the solenoid or a shorted solenoid. If the fault line went to a 1 when the car was commanded into third or fourth gear, then it's a solenoid B fault. So you had to run the car through the gears and monitor which gear the car was in when the fault line changed status. That's how you figured out what the fault was and which solenoid circuit had the fault in it. So the Cadillacs were a little bit different. Now, starting in the 1996 model year, Cadillac moved away from onboard diagnostics. They went to scan tool support. So the scan tool support itself, again, gets confusing for people because the way you would think that somebody would write things out and the way they actually write it out in the software that you see on your scan tool are two totally different things. As we talked about earlier, we had the output driver feedback lines represented good and bad by 1s and 0s. They don't do that on this thing now. The parameter display itself is going to be displayed as shift solenoid driver number 1 if you're dealing with the 1-2 solenoid. And it will display, just like we talked about with an output driver module, an ODM, giving you in simple English what the failure is. Is it okay? So if it says okay, we're not broken. It says open or short or overcurrent. That's the display you'll get. Solenoid driver number 2, it does not say 2-3 solenoid in the scan tool. It says solenoid driver number 2. It will be displaying the 2-3 solenoid status. And again, it's either going to be an okay, an open or short, or an overcurrent situation here. TCC driver is for your TCC PWM solenoid. So by looking at that TCC driver circuit, as you can see here, we're going to have the same kind of displays. So we're going to give it to you in simple English. So all your later model Cadillacs, including clear up to the end of the life of the 4T80Es, they gave the displays just like we're talking about here. So with that said, we're going to give you another question. So during normal feedback operations, when the solenoid is commanded on, what should your feedback value be? So this is the ones where we're having the matching status. So or you should be seeing popping up on your screen here in a second. The question, take a second and answer your question. So if it says on your command, what should the feedback read? If the car is not broken, what should it read? We'll allow a few more seconds. Looks like we got everybody that's voted, so I'll close it out. And we'll share the results of this. Looks like everybody pretty well has it right. The correct answer is B. Solenoid command status should say on. So if it says on command, feedback should also say on. Very good job, guys. All right. Well, that ends our presentation for today. We'll take a second here. Does anybody have any additional questions that you'd like to ask? Okay, you do have a hand there if you'd like to ask a question, obviously, and be on the broadcast live, or you can type in your question. If not, we certainly appreciate everybody's time. You can contact Lance Wiggins at lwiggins@atra.com if you have any additional questions that you'd like to ask, and we'll certainly answer those for you. So again, with that said, thank you guys very much for your time, and have a nice day. We'll see you at the next ATRA webinar here in about another week.